All right, the next thing we're going to talk about is interval of convergence. So College Board, it seems lately, has been putting a lot of interval convergence FRQ questions. And then when they do, it's usually a 5-point or a 4-point question. So they're usually kind of a big pointer. So our idea behind the interval of convergence, we're trying to figure out for what x values will make this series right here converge, right? So we're trying to figure out what is that, what's gonna make that happen. So what we end up doing is we end up doing the ratio test. And usually you're gonna get some points for setting up the ratio test. You need to show your limits. Some students get lazy on their ratio test and they just write, they write n plus 3 to the n plus, so x plus 3 to the n plus 1 over n plus 1, 5 to the n plus 1 times 5 to the n over x plus 3 n. They just write this, and then they simplify it, whatever. You're not going to get points. College Board's not going to give you the points. You need to make sure that you are showing that you're taking the absolute value, that the limit as n approaches infinity, and we want to show that this is less than 1. That is the whole key to this, right? If the ratio test yields a result that is less than 1, this series converges absolutely, okay? If it's greater than 1, it would diverge. So we're really looking for what we're looking to really solve this inequality. That's really what's happening right here, okay? And so a couple things we can do in here is we can simplify this. And so some of y'all, if you're getting good at simplifying these, you don't have to completely do it the way I do it, but I like to separate these out. Like see, this is the same thing as x plus 3 to the n plus 1. We have this n plus 1 here. This would be like 5 times 5 to the n. And what you're going to realize on all of these ratio tests is what happens to the polynomial portion. What happens is polynomial portion, what happens to those? They're going to go to what? 1. They're going to go to 1 because you take the limit as n approaches infinity. N over n plus 1 as n goes to infinity is 1. So those are all going to go to 1. So that's really kind of like applying the limit right there. And then otherwise, we're just going to simplify and reduce out all of these common factors. And so this n over n plus 1, when we do the limit as n goes to infinity, goes to 1. So really what we have to solve is this equation over here. We're going to have this x plus 3 over 5. The absolute value has to be less than 1. Okay? And so when we solve that, we can go ahead and put that between, basically for this to be true, x plus 3 over 5 has to be between -1 and 1 for that to be true. And so we're going to say -1 is less than x plus 3 over 5, which is less than 1. And then I'm going to go ahead and just multiply by 5. And so we have this x plus 3. And so we can see right now, we have a radius. If a question asks you for the radius of convergence, our radius is going to equal 5, right? Because we're going extending from the center, 5 each direction. We can subtract 3 from both of these. And we're going to end up with 2. This gives you the interior of the interval of convergence. It also shows us that the center of convergence is going to be at -3. Okay? We could have figured that out from the very beginning. We could also kind of figure out the radius from the beginning. If you do enough of these, you can start seeing the little patterns here. That's going to end up being your radius right there. Now, sometimes the question just asks for the radius, and it would be 5. Sometimes it's going to ask you for the actual interval of convergence, which the ratio test is inconclusive if you do a ratio test and it equals 1. That could be something, that piece of information that shows up in a multiple choice question also, right? And so in this case, we need to test the endpoints. We have to test both endpoints. And so we get x equals, I'm going to test x equals 2 first, because I think that's the easier one to test. And so when I plug in x equals 2 into the original series, I'm actually going to end up getting 5 to the n over n into the 5th, which these would cancel out, and we'd have 1 over n, which diverges, right? It's a diverging p-series. Questions over that? When I test at x equals -8, I'm going to end up with this series -5 to the n over n5 to the n. And realize, with a little bit of algebra, you can show that -5 to the n, that is really -1 to the n times 5 to the n. Those are the same thing, right? Okay. And so we would realize, is this going to, then we could actually say this series is really essentially -1 to the n over n. And is this one going to converge or diverge? This one converges, right? So this converges by the alternating series test. And so then we would go ahead and put equal to on that one. And this would be our interval of convergence. Okay. Any questions over that? Doesn't let me, there we go. Doesn't want us to stop recording.